transparency, and trust. With this, it gives me great privilege to introduce our esteemed resource person for today, Dr. Gargi Bhide Madam, Professor in the Department of AI and ML at Symbiosis Institute of Technology, Pune. Madam is an academician and researcher specializing in artificial intelligence with expertise in multimodal AI, explainable AI, and responsible AI. Madam completed her PhD in Computer Science, AI and Machine Learning at Symbiosis International Deep University, focusing on multimodal explainability in deep neural networks, and pursued a postdoctoral fellowship at the Symbiosis Center for Applied Artificial Intelligence. Madam's remarkable contributions include active participation in several prestigious national and international funded research projects in the areas of cognitive behavior analysis, drone technology, and explainable artificial intelligence. Madam's research portfolio includes publications in Q1 journals, Springer proceedings, IEEE transactions, and several international conferences. Madam also holds patents in the field of artificial intelligence and mental health applications. Madam is an IEEE senior member, serves as a journal reviewer and guest editor for special issues on explainable AI, and has developed specialized postgraduate courses on explainable AI. Madam's passion for academic innovation is reflected in her global partnership efforts with Aston University, UK, and the mentorship of multiple PhD scholars. Adding to her international recognition, Madam was awarded the Inter-Russia International Fellowship in 2005 in AI for Medicine at Novosibirsk State University, Russia. We are truly honored to have such a renowned academician and eminent researcher with us today. We welcome Madam. To extend a warm welcome, I request Dr. Dhanashree Kulkarni Madam, Atal FDP Coordinator, to kindly present a bouquet to Dr. Gargi Madam as a token of her respect and appreciation. Thank you, Madam. Now let's move ahead to the much-awaited session on explainable AI for mission-critical medical applications. I invite you, Madam, to lead the session. Hello, am I audible? Yes. Thank you all for giving me the opportunity to be here. A special thanks to Dr. Dhanashree Kulkarni Madam, AITM Management, Ability for Mission Critical Applications. So basically, am I audible to all of you? Hello, it's fine. So, how many of you are aware with the domain of explainable AI, or at least have heard about it, have some basic foundations to it? Good. So, when it comes to explainability, we should start with something which we call as responsible AI. Before knowing explainable AI for mission critical applications, we must know a paradigm that is responsible AI. So, in order to know it, basically responsible AI is a bigger tree and explainable AI is one of the branch of it. So, responsible AI deals with regulatory compliances, legal compliance, actions. Whenever you develop and deploy models, what actionable insights do you need?
accountability in the model. So in short, if we talk about rules and regulations, responsible AI is a paradigm that helps us in developing, deploying and adopting AI models across varied sectors. So when it comes to explainability in any of the sectors, first and foremost thing which the literature point out to or we need to understand is two terminologies. One is interpretability and one is explainability. If you see the literature of explainable AI domain, you will find these terms are interchangeably used across. Now, but there is a slight difference, a marginal difference which we need to account for. Not every system which is interpretable needs to be explainable and vice versa also holds true. What does this mean? For example, everybody knows machine learning. Everyone is aware of machine learning. Thank you. So, in terms of machine learning, we know we have a simple decision tree, right? We have a simple decision tree. You can build your decision tree from the root node to the leaf node, and you can trace back the decision tree in order to know what decisions are being derived by the decision tree, what outcomes are expected by the decision tree. But what if I stop you and at this instance I tell you decision tree at moments is least interpretable? You all will be in dilemma or a shock kind of. Decision tree can itself become that much complex that it is not interpretable or a human cannot understand a simple decision tree outcomes. So for you to understand interpretability and explainability, interpretability is something which you can interpret, for which you can know the decisions, and explainability is making a black box system come out of the loop and explain its decisions or predictions so that it can be established in a human understandable fashion. So that is the difference between interpretability and explainability at first. Everyone knows this, CNN, a normal convolution neural network. What I'm starting with, explainability, the domain in itself has admit like anything. There are tremendous amount of research which is going on in this domain. But why at first we need to do explainability is what most of the people don't understand. So if I'm talking in terms of CNN, the convolutional neural net, we all know it does feature extraction, classification, and a probabilistic decision making, which is at softmax layer that gives you the classification. Through all these layers, your class discriminating features or classification result is basically done at the very last layer, which is your probability or softmax kind of layer that you have, which establishes your classification probability for any kind of task that you deal with. If in this case, why to move for explainability in deep neural nets? Now, if we understand this, deep neural nets is just a collection of neural networks, nodes, and tremendous amount of collections. If this is what we know, what it is doing in a very simple and in a layman's term, it is just doing a function approximation. We call it as a function approximation. That means I give a certain thing as an input and it establishes, it just processes it and it delivers me the output. Now, in this pipeline of generating the outputs or generating the decisions or predictions, these systems, not even the developer or designers of these systems are aware about why and how these systems are making certain predictions. In order to understand this why and how context, we need explainability in place. And that's why we say a DNN is nothing just a black box which is least interpretable. If we understand this, what is the solution that we propose is to come out of the black box and make it interpretable for mission critical applications. Now I am using two terminologies to and fro. One is mission critical application, or it is also called as high stake application. What are these kind of applications? Just understand. If, for example, you are working with a recommendation system, you are building a recommendation system, and the recommendation system is giving you a recommendation based on a movie or for a song. If I get a single wrong recommendation, would that affect me? Would that impact me? No, not at all. What would I have an impact based on a single wrong recommendation? But now assume the case of the scenario like your healthcare based applications or autonomous systems or robotics or finance, fintech. So these are the kind of applications wherein simple performance, mere performance is not enough. What has happened with deep learning is when deep learning came into picture from AlexNet and the era which we know, deep learning has taken over the market with the knowledge base that it can provide tremendous amount of accuracy to any kind of predictive tasks. This is what we know. But I don't disagree with it, it's totally true. This is possible due to the computational resource and the amount of systems we have these days. But if it is a black box, mere accuracy will not help you. You need to come out of it and establish trust, transparency and accountability so that a doctor or any layman would understand the predictions about why and how a certain decision was made. So this is our basic goal. Here, as I said, lot of business risk is involved. You may be knowing these kind of cases about IBM Watson, which was deployed for mission critical cases, and then they have to take back IBM Watson deployed model due to the funda that IBM Watson was full of biases. So machine learning and deep learning based systems are very prone to perpetuate biases through the data, through the model, and since there was least explainability in place, what was the scenario? They need to take back the deployed model. So there is a lot of business risk that is involved in mere deployment without understanding. One more agenda for explainability to come in place is the acts and laws that are established by the European Union. World over, there are lots of laws that are established. GDPR is one of them, General Data Protection and Regulatory Act. This is an act which is established first by European Union. What this act says, for any kind of mission critical application where life of the person is in danger and some decisions are made due to automated decision making systems, the person who is suffered by this kind of decision making has full right and authority to ask for justification why a specific decision was made and on what basis it was made. So GDPR is one of the regulatory act that makes explainable AI compulsory for mission critical applications. One of the challenge of deep learning and machine learning, one more challenge is adversarial attacks. Maybe you are familiar with this or not. Adversarial attacks are prone, all kind of machine learning based systems are prone to this kind of attacks. When a specific machine learning system or deep learning system is having an adversarial attack, what exactly is happening inside? Whatever input image you provide, any kind of input image you provide, those input images are perturbed. There are certain changes that are minute changes which are negligible. It's very hard to perceive those changes through a bare human eyes. But this kind of small manipulations or perturbations are made in the system, and due to this what happens? The system which was previously identifying an image as a panda is now identifying the same image as a gibbon. So this is an adversary that is being introduced in the system. So explainability is one of the measure to combat adversity. One of the measure to combat adversity is explainability. So adversarial attack is one more challenge in the field. So for all the challenges mostly which you see, bias, fairness, adversary, for each of the challenge which you just put forth before me, I can propose a solution based on explainability for you. One of the major and I should say this is a primitive challenge in the field again is with the performance explainability trade-off. This I can establish well with just now example which I gave about the decision tree. Decision tree known as a interpretable architecture or a data structure can become more and more complex and least interpretable day by day. So the problem here is if I try to improve on accuracy, if I try to improve on performance, I am making my systems least and least interpretable. Now here I need to fix a goal. What I want to make a system more accurate or whether I want to make a system interpretable or explainable. There is always a trade-off. If you choose explainability, there is a problem. Why a problem? Because if you assume to have explainability on top of your model to make it understandable from human perspective, you need to have extra computation. That is the problem. So how to balance this performance and explainability trade-off is one of the challenges in the field right now. And whatever I am talking in terms of explainable AI is applied to any kind of mission critical application. Healthcare, robotics, autonomous systems, fintech, you just pose the application and it is applicable. So XAI started with the DARPA proposed model at first. DARPA is basically a US based military defense organization that felt the need of explanation before actual deployment. So primitive machine learning systems were this kind. You had your training data, you had the machine learning process, it was learning a function, as I said, through function approximation, and it was giving you the decision making or your predictions. But now here I have tremendous amount of questions to ask. How were these predictions made? On what basis these predictions were made? Can I understand the inner underlying pipeline on the basis of which these predictions were made? Then, what are the chances of this kind of systems if deployed? What are the chances of success or failure? Can you confidently say that my system will succeed or it will fail terribly? So there are tremendous kind of questions that through which we are trying to explain and have an explanation interface on top of it so as to have a proposed solution for any kind of problem. So how an explanation system would look for any kind of machine learning problem, you have your ML model, you have your data, you have your ML model with some kind of generalization error which we assume that this error exists in all the models, bare minimum error, generalization error. Now when you have a system that is interpretable, here you have a top-up layer of interpretability which states that we call this as a human in the loop approach. This is a kind of approach which focuses on human-centered AI. This is an approach proposed by human-centered AI and a part of human-centered explainable AI. That means humans should be at the core or center of these kind of systems, and for whatever domain or application I am building a system, let the domain expert be in the loop. If it is for healthcare, let the doctor be in the loop. If it is for law, let the advocate or the judge be in the loop. So this is how we build domain knowledge infusion through machine learning and keep domain expert in the loop. And we also say this as a proposition for human AI collaborative tasks. Then when I'm explaining, my goal is always explainability when it came into picture picture, through literature, people thought it was explanations that were built for artificial intelligence based systems, and it's trying to explain deep learning models that are more complex, so they are not human interpretable. That's why we need to build some top-up layer and try to explain them a lot. But here again there is a perspective, explainability. Working in this domain since last 6 years, I can tell you it's not that simple. What it is proposed like. Here point is you need to have only technical perspective for this domain is not enough. You need to have a diverse, interdisciplinary, multifaceted perspective of these many fields. What are those? A blend of AI, a blend of human-computer interaction, HCAI, and a blend of social sciences. Now you may ask me why, madam, social science is required for this kind of field. For example, I am proposing some solution for, let's say, you have your radiology-based application wherein you are predicting based on certain kind of modality whether a person is being diagnosed for a specific disease or not. It's a simple kind of classification problem. I am providing explanation to it, and then based on the explanation provided, this is not a free lunch theorem. Here we have a theory called as no explanation fits all. What does this mean? Consider a medical use case. You have your doctor. What are the stakeholders in medical applications? In a clinician pipeline, you have the doctor as a stakeholder. Major perspective is patient-centric. So patient is the main stakeholder for whom you are building or accounting systems into. And then you have regulatory compliances. You have developers, designers, and so on and so forth. Variety of stakeholders. But major stakeholders are doctors and patients for a healthcare use case. Now, if I'm building something which is, I'm trying with a goal to satisfy the doctor at first, that essentially would not satisfy the patient. You cannot build at a time a single system that satisfies the patient as well as the doctor. Why I'm saying this? Explainability in terms is a very subjective term. It's very subjective term. If I give an explanation, maybe she will be satisfied by my explanation. At the same time, Pam won't be satisfied. So that this ambiguity, there is always ambiguity between the satisfaction levels. And this is a subjective matter, hence it is a psychological domain as well. So hence you need to have a multidisciplinary perspective of all these domains to explain. Then why we are explaining? We are trying to explain so as to justify our prediction. We are trying to explain so as to have regulatory control. We are trying to explain so as to improve the accuracy of your models. We are trying to explain so as to discover. Why I am saying I am explaining for discovery? Discovery is I can identify flaws, I can debug systems and identify flaws in my model. So when I am identifying a flaw in my model, that is a discovery for me. So explain to discover. So these are the perspectives which people have. Then as I said, there are diverse explanatory requirements for any kind of application which you talk about. You need to have purpose. You need to understand the type of users that are going to consume your explanation at first and foremost. Then you need to build upon what kind of methods, techniques and terminologies you are going to use so as to explain. And then you need to think about the application. If it is a healthcare application, autonomous driving, what kind of application it is for which you are dealing or trying to explain. So there is each application has a diverse kind of requirements that you need to fit into. So the next point comes as dimensions of explainability. When you are trying to explain something, you need to understand three terms. You need to understand first the data, second is your prediction, and the third facet to it is your original model. So data, when I'm understanding, let's say, let's assume a use case wherein we are predicting for an already admitted patient how long would he stay into the hospital. For how many long days we are predicting the stay of the patient. So you need to understand what variables and features are relevant to my prediction. You need to understand why certain patients are predicted for long stay and why others are not. Here there may be a case of bias as well. Many healthcare use cases have seen uh, premature deployment, and they have seen that there are lot of perpetuating biases based on age, gender, ethnicity, caste, creed, demographics. So we cannot underestimate the bias wala perspective. We need to have it. And model. So what are the patterns that the model is looking onto so as to identify the patient stay, also as to identify what kind of predictions. Basically in medical domain, as per my knowledge, mostly systems are built for prognosis, diagnosis, treatment plans, actionable performances, and then probability of readmissions, predicting stays of patient. And nowadays there is a boom in a field which we call as personalized medicines. So personalized medicines or precision medicine. This is also a term called as precision medicine. So for all these perspectives, you need to have explainability in place. Then only you can deploy some model or adopt it into real life use case. So as I said, when you are making a high stake decision making, you need to have fairness. This is fairness in terms of non-discrimination. Fairness in terms of non-discrimination based on age, gender, ethnicity, caste, creed, demographics. Biases are continental, geographical. Lot of biases, data and model biases are perpetuated day in and day out. So you need to think of that. You need to think about the high impact consequences that this kind of model will result into. You need enough. What does this mean? For a specific healthcare application, if you say, Madam, my model gives me 96% accuracy. With 96% accuracy, it is saying that this particular person is having a benign tumor or a malignant tumor. This 96% of accuracy is of zero use when it comes to healthcare. Why I am saying so? I am making a very bold statement. Point is, when you are dealing with healthcare like sector, you need to look for false positives and false negatives. That's why we say healthcare is the only sector where we need high recall in applications, high recall in results. So the point which I want to make very clear, accuracy mere is not enough unless and until you know how and why a particular decision was made. In any mission critical application, mere accuracy should not be used as an evaluation metric. Utility wise, we discussed this point for end users and all. So, when it comes to explainability, there are two perspectives. One is you have intrinsic explainability into the models. By intrinsic explainability, we are building models that are intrinsically in self-explanatory in design. These can be built through attention-based models. These models can be built through attention-based kind of infrastructure. And second form of explainability is post hoc explanation or explanation that is derived after the model is even developed and deployed. So the ideal form of explanation which you can build is right from the model development stage to the design, development, deployment and adoption through all these stages. But mostly what is observed is people build post hoc explanatory applications. Post hoc is more prominently used. Then based on these post hoc explanations, you can have further two categories of explanation. One is model agnostic and other is model specific. What are these two kind of terminologies that are used? When I say model specific, that means the explanation, whatever is built, just applies for that specific model. It would not be workable or actionable when outside the model. That is model specific. When I say model agnostic, it means independent of the underlying model. It's totally independent of the underlying model. It's not at all dependent on what kind of features the model is using, what kind of attributes, parameters, variables. It's totally independent. It can work post hoc. So there are two. What type of questions are answered through explanation is what drives my model prediction, what did my model take a specific decision, and how can I trust my model. Now when I say trust, I was talking about responsible AI, right? I provoked on three terminologies: trust, transparency, accountability. So when I say trust, trust is again a subjective matter. To what extent to trust? How much to trust? Whether to trust or not to trust? It's again a subjective and dilemmatic matter. So establishing trust is difficult at this stage. When it comes to explainability, this is actually what I'm showcasing you right now. Right now, the taxonomy which I'm showing to you is my PhD work. This is my PhD work basically, what that I did. So my PhD was basically on whatever use cases I am going to discuss today with you are the work that I done during the period of my PhD or postdoc. Either of them. And the work carried at our center, we have our own center, Symbiosis Center for Applied Artificial Intelligence, that is headed by Dr. Ketan Kotecha, the Dean and Director at Symbiosis International University. So most of the work which is done under his flagship is what I am showcasing. And he, by God's grace, he was my PhD guide. So I was very lucky to have him as a guide so that I can do this much. So when it comes to XAI taxonomy, you have four kind of working principles. Basically, you have one kind of explanation that is totally model dependent, one kind of explanation that you derive based on scope of the explanation. Now, when I say scope of the explanation, it has two virtues. It has two virtues. One is local explanation and the other one is the global explanation. So what is a local explanation? For my machine learning model or deep learning model, whatever example you take into account, if I'm trying to explain a single data point, understand? If I'm trying to explain a single data point in my model, that is a local explanation. When I'm trying to explain the entire model as a whole, that is a global explanation. So there are two facets to it, and based on the stage at which you are deploying explainability in the model, that is whether during the pre-modeling stage. When I say pre-modeling stage, this is basically the stage that we call as the EDA, exploratory data analysis. Pre-modeling is your EDA stage, and majorly this accounts for data visualization and data pre-processing kind of stage, right? Then you have your post-modeling stage. In the post-modeling or post-hoc applications, you have surrogate models. Do you understand the surrogate model? Surrogate. So surrogate model is not the actual model. It is a model. Suppose I have a black box model. I don't know how to explain it. What I can do is I can build a surrogate model, which is the second model on top of the first original model, actual model. And now this surrogate model will explain me the predictions of the original model. Original model was non-interpretable, right? Least interpretable, black box. How to come out of the black box? Or and make it as a white box or a gray box is to come out of it through a surrogate model. Now, when I say a surrogate model, this surrogate model, you never know whether the surrogate model is faithful or not. I'll touch to this point afterwards soon. So, my PhD was basically on explainability for multimodal models, as Madam gave my introduction. What are multimodal models? Healthcare as a sector has lot of heterogeneity. Healthcare as a sector has lot of heterogeneity. That means there are medical reports, there are radiology, medical imaging. You have a report, you have a imaging. That means you have a vision, computer vision in place. You have a NLP. Report is your language, right? Natural language. You have NLP in place. So this is the kind of scenario wherein you have heterogeneous data sources and heterogeneous modality. I can pose you an example. For a single patient, you have his reports, you have his X-ray, you have his CT, you have his MRI, you have his, let's say, blood reports, blood samples, you have his genomics, right? So now each channel that I talked about right now is a channel of information for me. Each channel is a channel of information. So if I have a chance to integrate or fuse these modalities or channels across, then I can have a comprehensive and holistic perspective for a specific use case. Agreed? This is same as human perception. Human perception is multimodal in nature. You have your perception built through your senses, and you have your 5 senses that work aligned. Then only a perception is built. In the same way, if we are able to extract information that is coming across diverse healthcare channels, then I can establish a comprehensive and holistic treatment plan or actionable insights for a specific use case. This is what it is. So, when it comes to explainability for multimodal models, you cannot have a single perspective. It is more complex than what unimodal was. When I say unimodal, it is only vision or only language. When I say multimodal, it can be vision, it can be language, it can be video, it can be sensor as well. So, pura khichdi of all the perspectives. Actually, it's a blend. So, when you're building models for multimodal, you have visualization. This is the XAI taxonomy that I proposed as a part of my PhD. You have visualization, distillation, intrinsic, backpropagation, perturbation, local approximation, model translation, attention, and joint training approaches. So these are what explainable approaches that are already known to human beings. But how to extend these individual explainable approaches for the multimodal domain is what the challenge is. Then, this is first and foremost, if you ask me how to build explainability, I will suggest you try to have inherently explainable models. What does this mean? Unless and until, see, what people tend to do is, they are very fascinated by deep learning. I usually tell my students as well, when a simple machine learning is giving you a solution, don't go to deep learning for mission critical applications. It's just fancy, but it doesn't have that much interpretability. So when you're trying to explain something, use inherently explainable models like decision tree, random forest, XGBoost, ensemble based models Why not to use them? Why you need to have a complex DNA in picture at the first place? So I always promote inherently interpretable models at first place. Then the very known model across for explainability is LIME. Maybe most of you may be knowing this. LIME is local interpretability model agnostic explanations. I am not touching on all the explainability approaches, but I am just touching the explanatory methods that are widely used across healthcare sector. So LIME is one of them. Local interpretability model agnostic explanation. Model agnostic, it is independent of underlying model. Local interpretability, that means it is trying to explain a single point of explanation. How line works at first place, it is a model which is trying to predict a data point based on its nearby vicinity or based on the nearest neighborhood or likelihood approximation theorem, which we know. So line is one of the most prominent examples coming out of this category. But when I started the field of explainable AI, started researching in the field of explainable AI, I understood that there are a variety of models that are in place, but for a specific use case, let's say for diagnosing whether a person is suffering from cancer or not. Simple use case. For this kind of simple use case, if I apply line for that use case, for building an explanation, at the same time, if I apply SHAP, if I apply GradGAM, if I apply IG, integrated gradients, as many explanations I apply for a same model, what do you assume or desire to be as the end result? Any thought on this? What I say is, I am applying for a same use case, I am applying diverse explanatory methods. What I expected was, they should give the same kind of results. But what I found was, it's not true. If you apply, on the same use case, you apply 5 to 6 explainability methods, you will find every explanatory method is giving different explanation, different kind of explanation. Why this is? This is because the base on which these explainability methods are built, the kind of approach that is used is not similar. Some of the methods are this kind of approximation based, some of the methods are gradient based, some of the methods are counterfactuals. I'll touch into this, but there is a variety of stuff through which these methods are approaching, and due to this, you cannot have a single explanation that fits all. This is the problem. So when you know this, then how to build up a holistic explanation that will solve a complete, that will act as a complete solution for your problem. That is through an approach we call as multimodal explanation. A kind of single unified architecture that can propose solutions for all the different stakeholders. So these are already explainability methods that are available in the unimodal literature. Your layer-wise relevance propagation, these kind of approaches are already there. Now, a very new approach which you should focus on and future of explainability lies here. So future of explainability lies here. Why I am saying so? If you observe deep learning is just a function approximator, garbage in, garbage out. So when you are approximating a function, that means you're not looking at cause, effect and impact. Your human psychology, that's why I said it has to have a flavor of social sciences. It has to have a flavor of social sciences. Human psychology learns things through cause and effect. We things better through cause and effect. I failed the exam. Why did I fail the exam? Because I didn't study well. So there was a cause and there is an effect. So medical science is also a cause and effect based application. So you should build counterfactual explanations for medical science. So this is future of explainability through counterfactual building of explanations, where you are trying to understand or say, I got a specific decision, I know this is the decision, but now what can I do so as to flip the decision? This means I failed the exam, but now what can I do so as to pass the exam? It can be study hard, have an agenda, have a foolproof actionable plan, have thorough domain knowledge. It can be anything. So what I can do so as to flip the decision to the counter side. This is the counterfactual thinking. This is a counterfactual thinking, a human perspective that is integrated in the field of explainable AI. So you have situations like climate change, weather regimes that resulted into pandemics, that resulted into migrations, and that in turn resulted into mental health disorders. Now, what can I do if I want to reverse this loop cycle? I need to focus on these parameters and the final outcome. So I need to flip the decision. That means I need to go in terms of machine learning. I need to go to the other side of the decision boundary. How to go to the other side of decision boundary? By building counterfactual explanations that are not approximation based but are causal. These explanations are causal. So when it comes to evaluating explanation, you can have building explanation is okay. How to evaluate the explanation? You can have three perspectives: application grounded perspective, a human grounded perspective, and a functionally grounded perspective. So these are three perspectives for building explainable systems. Through these two perspectives and through human AI collaborative tasks, you can try for building evaluation plan for yourself. Now when it comes to evaluating explanations, when you are evaluating your models at first hand, what do you use? You use accuracy as a metric, you use precision, recall, F1, AUC, ROC, and all. So these are your primary evaluation parameters, right, or metrics. When it comes to explainability, what kind of evaluations can you have? You can look for if explanation is built, that explanation is faithful to my underlying model or not. So faithfulness, I was talking about trust. So faithfulness is something that would account to trust. So if my explanation is faithful, it can be trustworthy. So faithfulness is one that I will look for. This is a kind of sanity check or model vetting that is being done to check whether explanation is found to be faithful or not for the underlying model. Then you can check for fragility of explanation. What is fragile? Fragile is something that is easily manipulated, easily perturbed, changed. So if I have a robust explanation that cannot be perturbed easily, that means it stands for fragility as a metric. So you need to check for fragility. You need to check for stability. As I said, if you use surrogate models for explainability, then those kind of models may not be fulfilling the view or the perspective of your underlying model. Maybe underlying model is justifying something and your surrogate is focusing on something else. This may also happen. So that's why stability or how changes made in the input are impacting the final explanation is what you need to look for. Then apart from this, you need to also look for sensitivity of the attributes, sensitivity of hyperparameters, hyperparametric unit process and all these things. Then major, we were talking about adversarial attacks or adversarial perturbations in the field. So if image is identified as if a panda is identified as a panda based on a background, this is called as spurious correlation. This term in itself is called as spurious correlation, or it is also called as clever Hans movement. Clever Hans movement. Especially people working in NLP, they know these terms. And nowadays in transformers, we say hallucination and all these terminologies are used. So, how to check a specific explanation is effective or not? You have to use, when I say human-centric explainable AI, you have to be looking for user satisfaction, the mental model of the explanation. What does this mean? Human mental model, my model and explanation model, are they mapping to each other? Are they satisfying each other? That is a mental model check. Then you can check it through the task performance. You can have trust assessment test for explainability and correctability test specifically to check for debugging or flaws in the model. I'm just running fast because I need to discuss few use cases as well. So these are the explanation frameworks right now which we have. AIX 360, ELI 5, Captive. People interested in multimodal modeling, they can use Captive as a first and foremost tool for explainability. Most of them are established through Google, Microsoft or IBM. Most of these frameworks are either from Google, Microsoft or IBM. So AIX 360 was the basic explainability framework through which IBM came up, and then they have AIX 360 for AIS 360 as well for fairness and accountability check. So these kind of frameworks are already in place for you to use. TensorFlow, Keras, PyTorch, these kind of applications. They have PF explain and investigate. I investigate into place for explainability. Key takeaways from the domain is you need to know first why we are establishing interpretability. When you need to know the desires for your stakeholders for interpretability. You need to know well acquainted with the methods and applications for interpretability. And as I said, first focus on inherently explainable models or use bootstrap explainability at first place. If it is not solving your desired goal, then jump for self-explanatory models or models with inherent explainability such as attention. Recent days, there was debate in the field where people were showcasing why attention in itself is not an explanation. That's a huge debate on this. Attention is not an explanation. So there are papers saying attention not an explanation, attention not an explanation. So there is whether we can rely simply on attention as an explanation. So when I was working, there was the COVID-19 pandemic. It was through COVID-19 pandemic. So first and foremost explainability, which I thought to build up was for it's not working. Hello, it's okay now. So when I started with there was a COVID-19 pandemic in place. So during these times, lot of misinformation or falsified information about COVID-19 diagnosis was in the healthcare sector. Whether to use Covaxin, not to use Covaxin, whether to go with Covishield, not to. So a lot of misinformation and narratives were spread through social media platforms. So based on this, I found out a data set for huge data set for COVID-19, and then we built up our own data set. We augmented this original data set with our own data set, which we call as Mesovac as a data set, and this is an augmented data set. So basically, these narratives that social media platforms, all these narratives were captured through multiple social media platforms, Instagram, Facebook, were Twitter, multiple social media platforms data were taken into account, 5 to 6 platforms were taken into consideration, and the NLTK pipeline was run through this. And then on this, we developed a DAN kind of model. DAN is basically domain adversarial machine learning. So it's a part of domain adaptation. Do you know the term domain adaptation? Have you heard about it? A bit of. So basically, whatever we build in healthcare especially, source data is very huge, and it's same as the kind of a teacher-student network that you have. The teacher network is a huge source of knowledge base that is transferring the knowledge base to the student network. So we were working on domain adaptation in machine learning. So we thought of using domain adversarial machine learning over here. So we built a DAM model. Since we took data from multiple social media platforms, now perspectives and the content that we see across these data platforms are different. What does this mean? When I write a post on LinkedIn and when I write a post on Facebook, for example, I don't write the same kind of post. LinkedIn approach is more professional and the Facebook approach is more casual when you write something, right? So this means a post which is built for LinkedIn may not work for Facebook. So that because of the huge domain difference that is available, so you need to adopt from the richer source domain to the narrower target domain. How to fix this gap between two kinds of domains is through a technique in machine learning called as domain adaptation. And for this we build a domain adversarial neural network, and then based on this what we did is we collected multiple data from perceptions from multiple social media platforms, and then we first collected, classified those instances, then pre-processed, some form of data augmentation was also done, and then we predicted, built a domain classifier through which we predicted whether a specific narrative or a specific statement that was passed about COVID-19, whether it is a misinformation or a true information. So who will tell me that this is a true information or a misinformation? Obviously a doctor in the loop, the domain expert in the loop would be in position to tell whether it is misinformation or true information. So based on this, to justify the information as to be found to be true or not to be true, on this domain adversarial neural network, the DAN model which we say, we build an explainability layer on top of it to justify the explanations, and through a simple line model that we observed the source domain was news, Reuters, news agencies, and Twitter was the target domain, the precision recall and F1 using DAN model, domain adversarial machine learning, and without DAN is what you can see here. The results with DAN are always better since it can adapt to your source domain very well. Your source domain is rich in terms of features and your target domain is not that much rich. That's why you need to adapt. As I gave you the example, adapt from LinkedIn environment to the Facebook environment through domain adversaries. And then based on this, we compared it with already existing methods as well. So the DAN model was found to be more robust in all the terms for establishing misinformation during the COVID-19 scenario, and this work was done under the SPARK scheme of Government of India. Do you know SPARK? SPARK is after going from here, you look at it, there are very good schemes from the Government of India which we as a researchers should look onto. One of them is SPARK. SPARK is scheme for promotion for academic and research constituency. for Indian researchers. So one of the scheme under which we published this work. And then these were the results across the sources like Twitter, Instagram, Reddit, YouTube, and these results were built on the source data which we took from various social media platforms, and then we built our own data set through data augmentation as well, and that we named as Mizovac, and we tried this Mizovac data set to adapt to the source domain through domain adversarial neural training, network training, and then these were the results for the DAN model, and then we tried to explain the results of the DAN model, because DAN model, domain adversarial neural network, DAN, this is a black box model. So you need a XAI when you are deploying for COVID-19 kind of use case. You must be cautious to have explainability in place. We deployed a simple line model on top of this DAN. So simple form of explainability was given to it, and then line model was able to predict the scores based on the textual attributes and parameters that were seen in these kind of narratives that were passed due to vaccines. So instances of line were seen. And now when it comes to multimodal explanation, as I said, in multimodal is heterogeneous form of modalities. As I said, MRI, CT, medical reports. This is all heterogeneous data, genomic, proteinomic, all kind of omics data you have. So you have multimodal data with you and a heterogeneous atmosphere. Now, multimodal suffers from 5 basic challenges. The domain itself suffers from 5 challenges. One is representation, alignment, translation, fusion, and co-learning. Even though they sound very technical, though they are not that much technical, representation is how I represent my data. When I represent an image, I represent it as a pixel. When I represent a text, I represent it as a sequence, right? So, in the way I represent my data, that is representation. Alignment is when it is multimodal data, you need to have synchronization in terms of time and space across modalities. So that is synchronization is in the form of alignment. You have translation when I convert text to speech or speech to text. This is a form of translation which I do. And fusion is integration of modalities, infusing or integrating modalities so as to build a comprehensive outcome out of it. And then there is a challenge called as co-learning. We worked on this co-learning as a challenge. What co-learning means? Are you aware of transfer learning? Transfer learning. You have your source modality as a rich modality and a target modality, which is not that much rich source. Now you transfer this knowledge from the source modality to the target modality. This is a form of transfer learning. But when in real life multimodal use cases, it's not the case. If I train my data and on all the modalities, for example, CT, MRI, the medical reports, whatever modality I have, I can imagine. I have trained my model on this data, and now what happened is when you test it in the testing scenario, it may happen one of your modality is missing, or one of the modality may be noisy. Normal typical machine learning scenario. It may be noisy, it may be missing. How to deal with this? There is a fundamental challenge to it called as co-learning. Co-learning is a phenomena in multimodal when all the modalities were present during the training time, but when you are testing the modality, one of the modality is missing. So I am already assuming if my modality is missing, I am purposefully or intentionally dropping the modalities so that I can check for robustness. So one of the colleague, he was working on co-learning as a challenge for multimodal, and I was working on explainability, as I said right from the beginning. And then we both once thought, why not to integrate co-learning with explainability? Because we know these are the two challenges that the domain faces, so we can integrate. So we came up with a framework, we call it as multimodal explanation framework, and we propose this wherein we have the normal co-learning based explanations and the gradient based explanations which are derived through SHAP or local interpretability kind of line or SHAP kind of explanation techniques. So here co-learning was acting as a kind of explanation. Basically this is not an explanation technique in itself, but we try to propose an explanation with, this is a challenge in the domain, but we tried if this challenge can itself be used as an explanation. So we tried to build a co-learning based explanation for a multimodal scenario and propose this framework wherein you have a learned language, audio and video inputs, and then you extract all the features, independent features from the individual models, and then you build, once you extract this, you build your individual models, and since it's a multimodal scenario, by using multimodal fusion techniques, primitive or dynamic fusion technique or attention memory based fusion techniques, you fuse these modalities together. So co-learning, with the help of co-learning and the explainability techniques which are already existing, you can propose a explanation for the missing modality or noisy modality kind of a scenario. So here we observe, if you use single modality, the accuracy was dropped, but as you can observe through the numbers, the accuracy was less, but when you fused all the modalities, it boosted the accuracy and performance, and then this was even seen in terms of F1 score as well. If you observe this table, yes, purposefully one of the modality is dropped intentionally to observe the performance of rest of the modality in the missing or noisy modality kind of a scenario. So co-learning environment which we see. So these are the kind of results which we got, in which we can establish dominance of modalities. What does this mean? When I say audio visual speech recognition, AVSR as a task, audio and visual are synchronous to each other. Both are working coherently to build the final outcome, final impact that we have. But now if one of the modality is dominant and other is recessive in this kind of scenario, then your final impact may be affected. You may not get the impact that you desire. So in this case, co-learning can come to your rescue, and this is a way through which you can build robust models and explanations for this modality use cases. Then we also worked on projects like retinopathy of prematurity, ROP, in which there is a hospital in Pune, Narayan Netralaya, variety of hospital chains are there basically. They came up and they said there are problems related to cataract, problems related to diabetic retinopathy, problems related to ROP, prematurity, premature babies ka retinopathy. So variety of real world problems. Can you propose a solution to this kind of problems through building explainable frameworks? So what we did is we tried to explain the original scenario for cataract through line, grad cam, IG, smooth grad. Actually, this is not a new invention in any terms, but to the real world data we applied the already existing techniques which were in hand. Now, in order to evaluate this kind of explanations, you have a framework called as Quantus. If you know, it's well and good. If you don't know, you can check. This Quantus is an explanation evaluation framework. The parameters that I was talking about, faithfulness, fragility, stability, whatever parameters I listed, you can check the validity of those parameters through this Quantus framework, and it checks for robustness, faithfulness, localization, complexity and randomization as well. When you are working on object detection kind of scenario, OD models, localization is prime. Your evaluation matrix changes. You switch from accuracy to IOU and MAP or AP, mean average precision. Your metric changes. So based on task, you need a new metric to evaluate and you need a new framework for evaluation. So there are based on tasks, try and derive new frameworks so that you can evaluate same task for multiple scenarios. So Quantus is one of them. Then whatever explanation techniques we worked upon, we check them for faithfulness of these techniques through Quantus. Again, as I said, all the explanation techniques are not at all faithful. Diverse techniques gives diverse kind of explanation. No one explanation fits all policy again is observed here. And this is again one of the project which I need to discuss. We have time, 5 minutes at least. I took a lot of time. Okay, we can discuss. Thank you for this. Because this is one of the project again near and dear to my heart, lifelong memory. When I was working on my PhD, as I said in multimodal explainability, in the same phase there were a variety of grants that were passed through government, and on the multimodal domain we applied for this project under Ministry of Electronics and IT, MAITI. So this is one of the, I can say, elite project of Symbiosis, Center for Applied Artificial Intelligence, and one of the project in which I was lucky to work as a postdoc. I did my postdoc on this project. This is a project which is funded by Ministry of Electronics and IT, MAITI, in collaboration with CDAC Delhi and INMAS Lab, basically. Since I was working in the domain of multimodal, when it was observed, they said why not to do multimodal in the area of cognitive behavior analysis. Now cognitive behavior is not my domain actually, and it was very new to me, but I was knowing something about multimodal, I was knowing something about explainability, and I felt surely I can extend this knowledge through the facets of cognitive behavior. So basically when you are analyzing cognitive behavior in a multimodal fashion, you are basically intended to analyze, for example, stress, and detecting through machine learning or deep learning based systems whether you are stressed or stressed. Now stress in its multimodal, multiple modalities. What modalities did we consider? As I mentioned here, the objectives: lie or abnormality or malicious pattern detection, multimodal fusion methods analysis for this, and one and foremost context to this project was the context to build such a kind of system in Indian context. What do I mean? Lot of multimodal data sets are present that can detect stress, that can detect lie. Variety of data sets are available, but those are foreign data sets. There is no Indian context to them because that data does not belong to Indian population. So one of the primary objective that we placed here was to build a data set for Indian population with the Indian and demographics. So we collected data, multimodal data I should say, for 120 participants, and for which collecting the data of single person took me 2.5 hours. So when I invested my entire day, I could get data of only 2 people. This was due to the setup that I had for data collection. It was a tedious kind of setup, multimodal integrated setup. What modalities we collected, first I should showcase you on that. I am not completely revealing this project because it is under patenting and it is ministry project as well. So not a complete context, but an overview. So modalities such as EEG, medical modalities, EEG, ECG, EOG, ocular. EOG is ocular. ECG is you place here. EOG, ECG, EEG, audio, video, gaze. Gaze is eye tracking. And GSR. GSR is galvanic skin conductance. Your perspiration. Because when a person is under stress, he will have increased levels of all this behavior. Or whether when a person is lying, obviously internally he is stressed somewhere. So all these attributes are internally related, interlinked, and there is certain kind of correlation or association between these attributes. That's why when you are analyzing stress or deception multimodally, you need to have holistic association with all these modalities. EEG, ECG, EOG were already identified to be a known testing parameter for stress. And rest all, audio, video and gaze is also one of them. Audio video was not. So we collected the first Indian data set in the domain with 120 participants. It took me 1.5 years to just collect the data. So for us, even we say we aging process our started due to that data collection. We say this, and that is very true. Because imagine the scene, for one, you are investing your entire day and you get data of only 2 people. And that also you don't know whether it is reliable or not. You need to check, correct hai, wrong hai, whatever it is. So it's under such dilemma. But through this setup that was available for testing, we could collect this, and now we have already submitted the data to AI Kosh. Maybe you know AI Kosh. So we have already submitted the data to the ministry, and it is under patenting. So this is multimodal cognitive behavior, most national language kind of, which can be holistically analyzed through NLP techniques. Bashini and all divisions are already working on this. So, can we have this? So this was a thought. But here the point is, when we took data, the persons, the people from which we took the data are not themselves criminals. Are you getting? Those are normal people like you and me. The thing is, we set up experimental protocols and scenarios in a way that led them to lie. So that experiment also set with the help of psychologists. What makes people lie better? And now, agencies say you should have taken all actual criminal data. People who are in the jail. So those are actual criminals. So you get, that is the next phase. So, but setting experimental protocols in a way that through which you can judge and make people lie is a difficulty. So this is what we do at Sky at first. So right now, after postdoc, I have started working as in the department of artificial intelligence and machine learning at Symbiosis. I am currently working. So whatever knowledge I gained through my PhD and postdoc, I am passing to my research scholars now, so that they can build next generation applications. Let's see how they work. Any questions? I am happy to see questions. There are libraries that you can use in hand. I first worked on then you need to have this kind of hybrid approach. As I said, co-learning with explainability. You need to fuse two diverse things together to build your own technique. At first hand, you can use post-hoc explainability approaches that are already available. But if you want to build novel old techniques, then you need to go for hybrid fusion kind of approaches, where fuse variety of techniques together in the domain and try to build explanation at first hand. But the major part is people have worked on devising explanations, but very limited work is there in evaluation of explanations. So I feel explanation evaluation is the forthcoming research facet. Quantas was one, I tried it through Quantas, one of them was Quantas. But we should look for building counterfactual and evaluation parameters, more evaluation parameters for explanation in all the mission critical applications.
On behalf of the AITM, we would like to thank Dr. Gargi Madam for such an enlightening session. Thank you very much, Madam. As a gesture of our gratitude, I request Dr. Dharashri Kulkarni Madam to kindly present a memento to Dr. Gargi Madam for sharing her time and knowledge with us. Thank you to all the participants for your active involvement. Tomorrow our session will start at 11 a.m.
Thank you all for being such a successful audience.
Participants are requested to kindly take tea outside.
Thank you. ಯಾರಿಗೂ ಪ್ರೈವೇಟ್ ಶೇರ್